jump around a little here on day 2 of this if I see we're going to have some time issues towards the end, but I don't see why we're going to. So we'll just kind of pop in here and start working our way along. So, all right, we got 20 students in Spanish class, frequencies of their test scores. So, according to the info, how many students got a score higher than 69? Which groups would be included in that? Would I include all 4 of these groups? So would I include the 60 to 69 group if we're looking for numbers that are great? No. Okay. I do not want this one. So what I'll do then is I'll add these up. So I got 8 and 3 and 4 would be 15. But again, it's just asking for how many students. So I don't have to make my fraction here. I just write the number of students that are covered and I'd be done. Now, this gets a little bit more interesting. The median lies in which interval of the frequency table shown? You're like, but I don't know the numbers. So how am I supposed to figure out which interval it's in? Well, there's a couple of things I could do here. If you're really much more comfortable visually looking at this, what I could do is I could just put a score from each one in. So like there's one score from 50 to 59, so I'm just going to use 50. There's 4 scores in the 60 to 69, 8 in here. So I'm just going to use the same score because I'm not looking for the exact median. I'm just looking for what interval it's in. So as long as I write some number from that interval in there, and then I'm hoping I'm going to be able to show you guys a way that you might be able to do this a little bit quicker, but we'll do it this way and then we'll see if we can figure that part out. So again, didn't come up with specific numbers. All I did here was say, okay, you know, I have a value in the 50 to 59 and I have 4 in here and so on. And then the median is, once I have them in order, figuring out what values in the middle. And again, I'm just looking for approximation here. So in my made up list here, it's 70, which would be 70 to 79. Now, could I have figured that out without writing all these numbers down? Sure. Well, how could you have done that? Well, here's another thing that I could have done. Instead of writing down numbers, check this out. I'm going to put a dot here. Just going to put single dots for however many the frequency says. You're like, okay. If I just have dots there, I'm trying to find the dot in the middle because I don't have a specific value. So I start from the lowest and the highest, and I just start eliminating dots on each side. And what you see ends up happening is I'm out of dots now everywhere except in the 70 to 79 range. So that's where my median's going to be. If they're not asking me to find a specific value, I can make it very, very general. So if you want to make a list and see the numbers, you can.
Because I put that into the cancel out.
You mean like with the numbers and they're all canceling as I go?
They all cancel.
You didn't end up with one in the middle? Or did you end up with 2 in the middle maybe?
Well, I got 2 in the middle.
And that's okay, but were they both like 70s?
Yeah.
Yeah, see, and that's the thing with these. As long as those single number or those 2 numbers are the same, they're both in the 70s, they're still going to be, yep, they're still going to be in the same interval. So it actually worked out just perfect still for you. So either one of those ways would work for me. But then it gets a little more tricky. The upper quartile, my Q3, lies in which interval? Now here's where there's an advantage of me having written this out this way. Because now I can look at it and Nope, not here today. Thank you. So I can look at this and say, okay, the upper quartile means I would look at these numbers and I'd find the median of those. So I just kind of start here and I'd work my way towards the middle and I find out I'm in the 80s. So I'd be 80 to 89. That may have been a little bit trickier just doing it with the dots because then I'd had to go back and recount. So that's where I might say doing the list is going to be a better idea. Okay? So, moving to the bottom. Which of the following sets of data values could represent the box and whisker below? Okay, I'm going to label things here first. So my lower extreme, my upper extreme, my median, my first quartile, my third quartile. So I look first to see, well, the extremes, are they going to help me? 3 and 21, 3 and 21, crap, 3 and 21, 3 and 21. But can I find one, and this may be my biggest help right here. Can I find one of these lists where the median is 12? Now there may be more than one list, but let's check to see. Maybe that'll help me out here. So let's try this out. Here my median would be 11. Well, I need it to be 12. Bad. Okay. Ooh, I'm being told it's C or B. All right, let's make sure here. Yeah, because 12 there. Okay, that would work. Yeah, it's 12 there. That would work. Ooh, if I add 11 and 13, that's 24. Divide it by 2. Oh, that's 12. Well, that one works too. So we haven't eliminated any more. I have no clue who. Oh, but it's East 145.
Yeah, sit on the door 148.
Oh, okay, because I was just looking at that, seeing the East 145. Because, yeah, I don't know who either of them are.
Okay. Sorry about that.
That's okay. So that didn't help me quite. So now I got to go to my quartiles. So let's say we try this next. So my upper would be 18. So let's test these guys out. Yep, that one's 18. Dang. That one's 18. What the heck, people? That one's 18. Well, we're just getting down to the nitty-gritty here now because I'm running out of things to be able to find. All right, let's do...
You're trying to find 9, but they all have 9 too.
They all have 3, and they all have 3.
Well, heck. What the freak? All right, let's see here. Gosh, maybe we're going to change the question. We'd like to do this on every sheet, right? Which of these following data values could not represent the box and whisker? A, we're going to move on. Oh, this is what I get. I borrowed this worksheet from somebody. I wonder if that should have said not, because, yeah, we just did all the data, and it works for the other 3. Oh, gracious. People can laugh later when they're watching this sometime. All right. We're smarter than the worksheet people. All right, let's see what else we got here. USA Track and Field Committee published the following report illustrating the comparison of lap speed and finishing placement of several top relay teams. So average speed of each team's relay and what place they get. All right. So based on the bar graph, which of the following conclusions is most accurate? The first place team was twice as fast as the fourth place team. Let's see here. That looks like that's about 7.5, and 7, and 6, and 4.5. Is 7.5 twice as much as 4.5?
Yes.
No. Let's see. The fastest time for the 200-meter relay was 7 meters per second. No, because we got one at 7.5. The first and second place teams were closest in time to one another. I'm with you on that one. Every runner on the first place team ran faster than the runners in the second place team. And you don't know that for sure, because maybe you had one speed demon and the other people were kind of slower. So definitely C on that one. All right, let's see what else we got. Ooh, this is a good one too. Okay, television network wants to pilot a new series in a city with 25,000 residents. So they sampled 1,000 people to determine the best time to run the series. Survey asked participants to state what time of day they watch the most TV. Table below shows the results. Now here's where I gotta watch it. Based on these results, how many people in the city watch television between 4 and 7? Now you're like, okay, that's easy. There, 322. And you look at the answers, you're like, but I don't see 322 anywhere. Here's the problem. What's that? Well, the 322 is based on your choice on whether to do, not your choice on whether to stop other people. So again, please just quietly. But I'm looking at the city that has 25,000 people in it. And that's how I'm going to figure out how many people are here. So, let me get the calculator out of the way over to here. I can do this one of two ways. I can either do 322 divided by 1,000 and then times it by the number of people, or I could do what I'd normally do, which would be to cross multiply, and you're going to notice I get the same answer, and then divide by the number that's with x, divide by 1,000. And I get the same answer either way, which is 8,050, which is letter A. So sometimes the chart itself doesn't tell you everything, it just tells you a small picture of what the whole story is. So be careful. I'm glad they didn't make 322 one of the answers, because that would have been tempting. So again, read carefully. Ooh, we're going to throw in a circle graph just for fun. Okay, why not? All right. Statistical Data Bureau published an analysis of incomes and expenditures of 100 average families throughout the United States. The circle graph below represents the Rosen family's monthly budget. Okay. If their total monthly income is $1,820, how much do they spend on food? I need to know what 30% of $1,820 is. How can I do that? Okay, let me ask it a different way. Would we rather work with a decimal, or would we rather work with the percent proportion? The percent proportion, okay. So if we do the percent proportion, the percent's always over 100. And the 1820 is how much money I have. I'm trying to figure out what 30% of that is. So when I go to do that, again, I'm going to cross multiply the ones that don't have x. So I'd have 1820 times 30. And then I divide by the number that's with x, which would be 100. And that'd be $546 a month they're spending on food. And that's kind of what we're working with here. So then, we're getting all sorts of graphs working here. This is good. So let's see. We checked Rover's water dish over a period of time. That sounds like a fun job. How long did Rover wait from the end of his first drink to the start of his second drink of water? So, okay. So the bowl's full. Here's drink 1. Then he waits a while. Here's drink 2. He waits a while. Because you understand the fact that when he starts drinking, that's when the amount starts going down. So he took 3 different drinks here. So how long did he wait from the end of his first drink to the start of his second? How many seconds passed? 30. From 30 to 60? I'm with you. So let's see what else we got here. Janae's first 7 French grades for the year are, here they are. What grade is at the 75th percentile, her Q3? So I got to put these in order first. So 78, 85, oh no, 80, got to be careful. 85, 87, 90, 91, 99. Now, I can't immediately find Q3. I'd have to find the median first. So, start counting into the middle. Okay. So there's my median. If I'm looking for the third quartile, I take the numbers after my median and go with the one in the middle. 91.
Versus the 7,
Yeah, that's the 75th percentile is the same as my Q3. Because when I'm doing these, let's just say, I'm just going to do this so we can see them all. If I'd have done my first one, okay, my Q1 would be at the 20.
What's the other word for Q1?
Lower, or the 25th percentile, or the lower quartile. Because then the median is my 50, and my Q3, or my 75th percentile, is that one, because it keeps going by 25s each time. Okay? So it just kind of, and they use all these different words, because they'll use 75th percentile, they'll use Q3, they'll use upper quartile. It's like you wish they'd just use the same word more than once, because it makes this kind of trickier. All right. So 28. Terry waitress 10 days the last 2 weeks. The amount of money she earned each day in tips are, how much money is at the 50th percentile or the median? So I guess we got to order them and find the one in the middle. So let's see here. Order them and find the one in the middle. Trying to make sure I don't screw this up. All right. Let me make sure I got 10 numbers here. Wait a minute. Uh-oh. Ah! That's why I always recount twice, because it was like I knew I was supposed to have 10 numbers and I only had 9. I'm like, what the heck? But I found my 10th number. So once I've got them in order, and I'm sure I have the right number of numbers, again, start counting in from the edges. Uh-oh. Well, let's see. Let's do it again. I got 2 numbers in the middle this time, so how do I find the median? Put them together and divide it. So 38 plus 42 would be 80, and 80 divided by 2 is 40. So it's not even one of my numbers. That's not very nice. And that actually just answers number 29 here. The median of any data set always represents the halfway point, the 50th percentile, whatever's right in the middle. So then 30. Ms. Michelson drew a box and whisker plot to represent her student scores on a recent math test. If Jennifer scored an 85 on the test, explain how her grade compares with the rest of the class. Remember, when this question's being asked, every piece of my plot, whether it's skinny, fat, whatever it is 25% of my data. If Jennifer scored an 85, what percentage of her classmates did she do better than? If Jennifer scored an 85, what percent of her classmates did she do better than? because she's way out here, 75. So she did better than 75% of the class. There's only a very small group of people that did better than she did. But that's the type of analysis we've got to be able to do. Not just she did good, okay? We've got to be able to explain a little bit more in detail than that. So 31 to 34. A number of text messages 10 different students sent in one day is shown in the box and whisker plot below. They should have zeros on all of those numbers. Maybe 2 zeros on all of those numbers, because I know that's not accurate. But, oh well. What's the minimum number of text messages sent according to the plot shown? What's 2? Okay, because that's my lower extreme. Good. What number is at the 50th percentile, or the median, according to the plot? Nice. On a roll. All right, let me move this up a little bit. Well, according to the plot shown, between what two numbers does half of the data lie? Okay, 8 and 14, because again, if I look at these as far as 25% go, if I look between 8 and 4, between my first and third quartile, I got 50%. Because the other ones, I get too much. According to this plot, how many text messages are at the 75th percentile? My Q3. So here's my lower extreme. Here's my Q1. There's my median. There's my Q3. So where's my Q3 at? We've got it labeled. Lower. My box is always made of my 3 quartiles. Q1, Q2, Q3. You're close. But we're always just looking for that last part of my box. That's always going to be my Q3 on these when I'm trying to find that upper quartile. If I was looking for Q1, I'd look for the first line making up my box. Are we getting? Oh, we're almost to the end. All right. So questions 35 to 37 refer to the following. All right, in order to pass the driver safety course, a person must answer 45 out of 50 questions correctly. The cumulative histogram below shows the group scores of a group of people who passed the exam. According to the table shown, how many total people passed the exam? Good job. 20. Now, some of you might say, but wait a minute. If you count all these up, 2 and 4, that'd be 6, 14, 23, 37, 57. Well, why isn't it B? When you talk about a cumulative histogram, notice some of the numbers get counted in, like 2 scored 45. 4 scored 45 to 46, which includes the one before that. And so they keep including the value before that on each one instead of saying this many people scored 46, this many people scored 47, this many people scored 48. They keep bunching them all together. So excellent. Well, then you got lucky in this case. So that's what was going on this particular one. So now this gets interesting. According to the table, how many people answered 49 questions correct? Now let's think about this for a minute. Okay, 9 people.
6 people.
You're close. 9 people scored 45 to 48. 14 people scored 45 to 49. What's the difference between those two numbers? 5. And that's how I'd figure that out. I just subtract the one before it to figure out what we've got. So according to the table shown, how many people received a score of 48 or less? I'm trying to give a hint here as I keep going in circles. Because, yeah, I was going to say, yep, because this column represents 48 on down, at least for what we have in the chart. So we've got this. Now, just one other thing I want to put on the bottom. I know it's not a question, but I know we also didn't do much of this while we were in this particular review. Stem and leaf. Okay. Remember, if I'm doing a stem and leaf plot, so let's say I'm given some numbers like, I don't know, 8, 27, 14, 19, 23, 1, 36, 27, 19. Okay, I'll just put a whole bunch of numbers here. When you go to make a stem and leaf plot, the stem is going to be the first number that you're looking at in this case. So what's the smallest and the biggest number that I see in the list?
1 smallest.
Okay. 1 and 36. Now when you have 1, you're like, but there's only one number.
Put 0.
My stem would be 0. So I'm going to have stems of 0, 1, 2, and 3. And then my leaves, so like with 8, okay. Now here's what I got to be careful of. Your leaves need to be in numerical order. So for instance, I notice I have 1 and 8 are my only single digit numbers. So I put 1, and then I put 8, because I want to put them in order. So then I'm like, okay, I'm done with those. What about the teens here? I got 14, and I got 2 19s. So I got a 4 and 2 9s. So you can have repeat numbers, that's okay. So then 2, I've got a 3, and I got 2 7s. And that gets rid of those. And I have one lonely number in the 30s. That would be my stem and leaf plot that I'm looking for. I just wanted to make sure we touched on that a little bit more than we had in the packet, even though it's one of the easier ones we do, but it's one I just wanted to make sure that you were aware of. Okay. Are there any other types of these that you're still kind of not sure of? Because we've got time. I can go back and hit anything you want me to if there's anything that's causing trouble at all. The quiz itself will be much shorter than this, of course. Why didn't we do page 6? Did I skip a page? Maybe we hadn't done this. Okay, well, let's go back to page 6 then. All right, let's see what we got. So back to page 6, number 16. All right, accompanying histogram shows the heights of the students in Kyra's health class. What is the total number of students in the class? Well, let's see. I'm going to put numbers on all of these. No. This is not a cumulative one. This one we've actually got separate groups for everybody, so we got to tally up all the people. How many people total do we have here 16. With you. Okay. So if you see the word cumulative or you see repeats in numbers, that's when we got to pay a little attention there. But a lot of times we don't have to worry about that. All right, height distribution of students in a high school math class. Total number of students in the class. Again, I've got to make sure that I figure out how many are in each pile or each bar, and then add them up that way. So how many students? What's that? 26. I think that's correct. 17. Oh, geez. Hardy, crazy, man. What crazy thing have I done now? Oh. So if you're looking later going, Hardy, you don't know how to count. It's true. 26. You had that like a minute and a half ago, and I'm sitting here can't figure out how to count to 4 and to 2. Okay, that's not good. Need to edit that part out later. Using the cumulative frequency table below, because notice they keep starting at 50 each time, how many students received a score between 70 and 79? Oh boy. All right, so 50 to 69, there were 12. 50 to 79, there were 12. So if 12 people got between 50 and 69, but I go up to 79, it's the same number of people. Because we said we're just going to subtract them. Well, heck, I guess nobody got any score in there. They all got the 50 to 69. Ouch. It's a lot of bad scores, but it also looks like there's quite a few good scores. Now have we completed the packet? I think so. So now are there any other issues that we have now that we've actually hit everything up here? All right, so tomorrow.